was Phillip Wesley's Equestrian Trails. And that was Kanaka Vai Vai by John Almeida. We'll taste of Hawaii. And that was the Makahiki festival that every year the Hawaiian New Year celebrates the Makahiki Festival, which lasts, I believe, from September through all the way through February and March. And we start celebrating right as the Pleiades sisters rise. And Kamailehua and Kamailehope are I believe that's Beta Centauri and Alpha Centauri. I will be right back.
Oh, that's great. There's not every astronomy club that gets to start its meetings with heavenly music. Kim, thank you very much. You're probably surprised that I don't look like Barbara. She's not here tonight. Other things, she had to take care of family stuff. My name is Doug Millar, and I'm on the board, and I'm going to take her place for a second. We've got an exciting meeting tonight. We have a great speaker, we have a great What's Up, and we have a bunch of books to give away. I saw one that had a $100 price on it before it was put in the giveaway bag. Oh, and we also have a telescope raffle. Yeah, so it should be an exciting night tonight. Let's see, what should we do? Oh, this is really, really important, and I want you to listen. If you show up here the second week in October, you will be alone. Well, there might be one or two other people looking like they don't belong to the club because they know that it's the wrong week. So you can all go to norms and talk about why we don't have the meeting on the same week every month. It's a scheduling thing with the university. So in October, Charlie, where are you? He left. He doesn't want to fess up to it. Charlie, when is the meeting in October? The 17th. So scratch it in your hand, 17th. But that's not the end of the story. I think November is a different week, isn't it? November is a week early. I've been coming to this club for 40 years, and except for 6 times, we've always met the second week in the month. And now we got 2 months in a row? Okay, Charlie, tell us. I don't want to be wrong. In November, when do we meet? You believe. Come on, I want to know what the date is. I don't want to show up here late. Okay, October is the, thank you. Say it again. 17th. Okay. November 7th. Is that the second Thursday? First Friday. Okay, November 7th. Every fiber in your being is going to start to say on the second week of November, I should be doing something tonight. Maybe I ought to put on my astronomy shirt. It's the wrong week. It's the 7th. Oh, University. That doesn't stop them in the summertime. Anyway, so it's October 17th and November 7th. Okay, now you're going to see me here anyway, but don't ask if I showed up on the wrong date, okay? Okay. All right. Oh, okay. I think we have some other announcements to go. And Kyle, who works in Delaware, who used to be a little kid in the club in Maryland. Sorry, what an insult. In Maryland. Here comes Kyle with the announcements.
All right, here we go. So welcome everyone. Welcome new members. You can find your name badges on the whiteboard. If you're attending the meetings online, they'll be mailed to you in a couple months. Coffee, donuts, and water are available for purchase upstairs by the entrance. The next ANSYS Star Party will be September 20th. The next astrophysics meeting will be September 19th at Orange Coast College. Astro Imagers will be October 3rd. The beginners class is also October 3rd online, and the next board meeting is online on September 28th. You can find more information about all the events on the website calendar. Mark your calendars for this year's Mars Society Convention. It'll be at USC October 9th through 11th. You can find more information on the slide about how to register for the event if you are interested in attending. The club's Adopt Scope program is up and running. So if you're interested in borrowing a scope or adopting a scope from us, you can go on the website. You can see here how to get to the Adopt a Scope program information, where you can find a sample adoption agreement and sample inventory. Our outreach events coordinator is Martin Christensen, and please contact him if you are available to help with any of these upcoming outreach events. They're always a fun time, so we highly encourage you to come out and help out if you are able to do so. If you have any items of interest that you would like to be featured in the Serious Astronomer newsletter, please reach out to Dave Fisher and he'll be able to review those items of interest. Friendly reminder to all those who use the ANSYS site, please remember to lock up the ANSYS house if you're the last one to leave, and ensure all the windows are closed, along with closing the gate to the site to ensure it stays secure. Also, when you're out there, please help with weed clearing if you're able to in common areas, and please make sure you do keep your pad clear of weeds to help with fire prevention. Our next general meeting, as Doug mentioned, will be October 17th, and I'll turn it over to John Garrett for the What's Up presentation. Thank you.
Thank you, Kyle, but not John Garrett quite yet. We're going to have a little excitement here. John, we can use you, though. You want to pull tickets? Okay, and I have my assistant. What's your name? Angelica? Yep, she's going to help me remember which number. Here's the deal. What? We're going to give away books first, and then we're going to give away a telescope. So the way the books go is I'm going to ask you to pick a number between 1 and 30, and it's not 1 and it's not 30. And if you pick the number, you get that particular bag of books. We got 6 or 7 bags of books, and they're good ones. I'm going to pick. Dan, are these yours in front? They're all hardbound books. These are pretty good, and it's heavy, and they're all astronomy books. Lots of good reading. How many people, raise your hand if you'd like to have this bag of books? Then I'll have you guess. You don't need any tickets. You just guess a number. What's your number, Suzanne? Between 1 and 30, not 1 or 30. You want the bag of books? Okay, what is it? Yeah. Okay. I have to tell her what number. Okay, what's your number? 21? 1, not 1 or 30. 9?
30. Yep, she's 28.
28. Anybody else? 50. Well, it's not between 1 and 30, not 1 or 30. 25?
1, 5, 15.
15, okay. Anybody else? 17. What number did I tell you? I said 8. Okay, who said 7? You said 7 and you picked 9?
Okay.
I get to whisper to her. I have picked a number between 1 and 10. It's not 1 and it's not 10. 5. What's the other one? Not 1, not 10, not 5. 4. What was the number?
3.
One, 2, 3, 4, 5 more bags of books. And these are not little paperback throwaway books. These are things that people have preened out of their library. I think I owe this to Dan Schechter. Is that right, Dan? Same thing, between 1 and 30, not 1 and not 30. Who's interested in another bag of books? Number? Holler it out. Oh, I got to give you a number.
What, 16.
16.
11.
11.
12.
12.
20.
20.
14.
Up here?
13.
13, okay.
27.
Any more? What was the number?
11.
Books. Can't lean over my back. 80 years old. Well, the rest of me is only 20 years old, but my back is 80. Okay, these are all these books are about meteorites, and the librarian has gone through for a section of books on a particular subject. And these are old books and new books, but this set of books is about meteorites. Hands up on, I got to guess a number. Okay, between 1 and 30, and it's not 1 and it's not 30. You heard that. Okay.
16.
16.
27.
27.
19.
19.
22.
22. 24. One more? What is it? 10.
22.
Oh, we got them. Isn't this fun? I can't tell you how relieved the librarian is. Now, if you donated some of these books in 1981, You might see some other ones. Ooh, right in the front is a Hubble book with pictures in it, hardbound book. 1 and 30, not 1, not 30. Wait a minute, I gotta pick the number. 22,
14,
23,
14,
13,
15,
what?
15,
15,
20.
20. Oh, you guys are good. 10, 19. Any more? 5. Okay.
21.
22. Anybody have 20? Yeah, 20. Okay, we'll do it again. We do 1 and 10. And 1 and 10, not 1, not 10. 6, 7.
14.
What's the number?
4.
Oh, there you go. So if you're thinking of going to Las Vegas this weekend, get into this and it'll wipe out all that energy and you'll be just as likely to win, more likely to win, probably. She told me what this was. This is all about comets. About 6 books on comets. Any takers? What's the number? And I'll say, well, if 15,
18.
18, 5,
9.
9, 7, 20, 6, 29.
13.
15. What?
15 is
I think 15 is close. We're going to do this every month until the library is down to a decent size. We have months of books, and it just gets better. First book is on space travel, history. Give her number, okay?
What's the number? That's
Between 1 and 30, and it's a Messier object number.
8.
8. Anybody else?
18.
18,
18.
25,
19.
25,
19.
19,
17. 1 already.
17, 21. Okay, what was the number?
29.
29.
The dust belt.
Who's 25? Who's 25? Okay.
All right.
This is fun. But you know what? Next month you can run us. I'm tired. Let's see. So we have the big raffle with Jake is going to present that. And this is really unbelievable that we have a couple of storage units of astronomy stuff that's better than this for the loaner scope program. And you can loan those out and buy them if you like. But this is stuff we want to give out to people and have them use it. So this is the raffle for, well, Jake, you tell them.
It's a scope, an 8-inch Schmidt-Cassegrain scope from Celestron. The model is the Nexstar 8i. There are a few things you should know about it. The 8i model has an option for a GPS alignment, and there's a couple of little caveats here. This scope started with the GPS accessory, but I can't find it, and I've been looking for months. So it has been demoted to an 8i, simple. I will describe what you can do. What I just tested it for this last week, it will align with the 2-star alignment. Let's see. It does track the sky tracking at the proper rate. The one thing I did not test was the go-to function, but it's supposed to have that, and I believe it probably works because the rest of the functions were working. So it's either considered a Nexstar Model 8 or Nexstar Model 8i without any options added. That's a pretty good scope. Yeah. Anything else? Let's see. It's missing the star pointer. It had it at one point. The star, I think I still brought it. The star pointer was non-functioning, so it needs a new one. That's about a $20 replacement. That's the equivalent to a finder scope. Yes. The tripod has one spoke is broken. I added a round disc to it to stiffen it up and got it to work fine. I expect that'll be improved by whoever comes up with the scope wins it tonight. And that's about it.
So the rule is, if you're here, you get a ticket. We'll put them in the barrel and pull out one and you're the winner. Not bad for a free telescope. Thanks, Jake.
Okay. See, I need some assistance to hand out the tickets and collect the stubs. You can use your help getting the ticket. I don't want to put the actual winning ticket. Okay. No. I am out of this.
So we took all these.
You're gonna.
One at a time. Come on. Okay. We have a number. And as soon as he gets his glasses out,
6687966.
oh, the librarian. Wait a minute. Jake, you better check this.
We will verify. It's
Is it Helen? That's 2 telescopes she's won. She won one in 1997 at RTMC. 96. It was a 10-inch. And she hasn't won anything since then.
He's gonna go to Canada.
Yay! Thank you, Helen.
You know, I've got that 12-inch monstrosity that I never used.
This is easy. You just,
I know.
you just unscrew it, take it home, and away you go. Well, that's so nice.
Sounds good, yeah. Okay.
So we'll get it all disassembled and ready for her, and then afterwards we'll get some little accessories and get you all set up so that you're not just going home with a monster and going, "What the heck is this?" So, and for those of you who might not be familiar with it, if you win something like this in the club, we have a beginners program, and you can take your telescope over there and learn how to use it. But on the other hand, you can also talk to Jake, and he'll make sure you get all the accessories and stuff that you need to make it work. I'm so glad they didn't go home with me. I was. I don't even know how many telescopes we have. I know what? I'd give it to Bill. He doesn't know how many he has either. Actually, he does. Okay, we ready to go? We're going to go to the regular program, and we've got to get all our screen set up. Are you ready to go? Okay. Yeah. What's Up Tonight is by our good friend John from Temecula, and always gives a good presentation. Here you are, sir.
Yes, I do. Yeah. Thank you.
Sure, I'll come out here. Yeah, thank you for inviting me to share this tonight. When I did my practice run through earlier today, it came up much short, and so I padded it a lot, thinking I needed to fill my full time. And I wish I could go through and take that out since this raffle and was really great. But I'll go as quickly as I can. Most of the pictures that I'm going to share, I've taken maybe sometime in the last 10 years. I had hoped to get out to a dark sky 3 weeks ago, but if you recall, we had a rather unprecedented rainstorm that weekend, and so I had to draw on some of my old pictures. And here's a picture. This time of year is one of my favorite times of year. It's like August, which is one of my favorite months, except the sun sets a little earlier. And so when you look into the sky to the south, you'll probably see we just lost the picture. Oh, okay. Yeah, they know they've lost. Anyway, when you look to the southwest, you still see the thickest part of the Milky Way. You see the constellation Sagittarius and Scorpius, and it always many years ago, I don't know who, someone pointed out that the Pipe Nebula, which is at the center of this picture, really looks like a horse. And once the person pointed that out to me, I can't unsee it. And so I definitely see the horse. A little invitation as to all can see the horse. And then here I'm going to enhance the image a little bit. Now, I hope you can see the horse. But it always amazes me how just a simple couple minutes of exposure with a wide field camera picks up that nebula, which I never see to the naked eye, but it's just really always a pleasant surprise at this time of year. Last chance to get it before it gets too low in the sky. Let me go over a few highlights from the planets. I didn't speak about all of the planets. I'm afraid the planets have become to me kind of like your second child. You have millions of pictures of the first one, but the second child, don't have so many. Well, the planets, I saw them. I really was enthusiastic about viewing planets 20 years ago, but now I don't get to do it. I don't take the time to do it so often, but I think I will. There's a couple special events going on this month that's going to rekindle my interest. I found myself on a farm in Indiana last weekend. My only camera was my cell phone, so I went out and snapped a picture about 5 o'clock in the morning looking east. And so here's the planets, Venus and Jupiter. And it's amazing what a phone can do. But when I actually looked at this picture carefully, I realized my phone made the planets blurry. But that's actually a good thing, because the one shot in which the planets weren't blurry, they were too much of a pinpoint to be visible probably in this venue. But anyway, nowadays, of course, you've got AI, artificial intelligence. And so you can always ask it, can you enhance the picture of Venus, for example, and might give you something like this. Now, that's an old joke, but I think it has new mileage now in the days of artificial intelligence, because artificial intelligence is notoriously bad at drawing the hands and fingers of a figure. So it seemed like a pretty good solution there. Anyway, so I used manual override and drew my own pictures of Venus and Jupiter on top of that. And one of the things that you'll see over the next month is that Venus is a faster moving planet around its orbit than Earth. And so it's going to appear to get lower and lower in the east, but it's still going to hang around with us. And you may also notice, if you look at it through a telescope, you may be able to still see a little bit of shadow on one side of it. And Jupiter definitely is going to stay there a while. It's going to get higher and higher in the sky. It's not moving against the stars as fast as Venus, but it's also the Earth moving around is making the Jupiter is going to appear higher and higher. So the times to watch for Jupiter are starting to begin, and it's going to get a good opportunity to see Jupiter. And other thing that I like about the morning sky right now, where you go out, you've got two good markers to appreciate how high the angle of the ecliptic is this time of year in the morning. So in the fall, the morning ecliptic, which is the path the sun tends to take and where we find all the planets, is tilted very high in the sky, and the evening ecliptic is very low in the sky. But this gives you a chance this time of year to see all of those fine particles scattered in the solar system, roughly in the plane of the solar system. When those scatter the light, we call that the zodiacal light. And so you may see that. If I'd gone out maybe 45 minutes earlier from the time that I took this picture, I might have been able to see the zodiacal light. So now is a very good time to watch for it in the morning sky, probably an hour before sunrise. And I don't have any good pictures of Pisces, the constellation Pisces. I've actually don't even remember if I've seen the constellation with my naked eye, because I think it's such a faint constellation. In fact, I'm nearly a Pisces denier, except this one picture I took a couple years ago in the winter has Pisces in it. So I'm going to borrow my winter Pisces picture. I'm going to just take the figures from it and rotate it to how you might see Pisces, Cetus the whale, and the locations of Saturn and Neptune right now in the evening sky. So if you look toward the southeast, you'll see Cetus the whale rising, and above it, you may see the stars Pisces. If you're in your city, you probably won't see the stars, but you will see a bright Saturn, and you won't see with the naked eye Neptune near it, but both in a telescope, you can try to see the two. I don't think they're close enough to see well in a telescope. I think they were a little while ago, but Saturn's still very close to prime viewing time. And another thing that's going on with Saturn is that I drew the rings nearly edge on. And so Saturn, we see Saturn's rings edge on. So we see the orbit of its moons nearly edge on. And that creates a rare opportunity for observing a transit of Titan and also other moons, one of which I need to see the name of, but it's blocked there. But I hopefully, oh, who knows? Who cares? Anyway, but I had the dates of those, and I don't have them quite memorized. So anyway, I think the night of the 19th, going in the 20th, if you stay up and start looking about 9:30 into about 1 o'clock, you may see Titan pass in front of Saturn. And so that is the one event that I realized I've never seen something like that. And I don't know if I actually could in my telescope, but I think I'm going to try. My daughter just got a really nice Dobsonian telescope with a good mirror. So I'm going to borrow that for about as long as it takes for her to discover that I've taken it and try to get a good look at with that. And then a night later, Tethys and another moon are supposedly going to pass in front of that. Oh, okay. I can view it on my this computer. Okay, so Titan transit September 19th and 20th, about 9:30 p.m. to 1:05 a.m. our time. Tethys and Dione transit about on September 21st, about 2:30 in the morning. They'll both be in front of Saturn. I don't know if you'll be able to see them, but you can certainly try. And so those are two things I'm going to try for that I haven't tried before. Let me go over a little bit of the deep sky. It's a wonderful time because you can still see the Milky Way spanning from the northeast all the way to the southwest. And so here I have a view of the Milky Way rising in the northeast. I took at the Palomar Observatory Campground many years ago. And you can see a couple of the constellations, a couple of well-known constellations, Cepheus the King, Cassiopeia. And over here is Andromeda. And Cassiopeia, of course, forms a very famous triangle pointer that almost points to the location of, hit two buttons there, almost to the location of M31. And that makes a great object in binoculars that you get a field of view like that. And then I gave away my joke, unless sometimes, binoculars like that, if your binoculars aren't collimated correctly, they might look like that. Anyway, I always figured that if AI takes my job, I'll go to Hollywood, collimating binoculars. There should be a lot of opportunity to do that. Anyway, up high here is the Lacerta, the lizard. And near there is a Delta, the Cepheus, a Cepheid variable, one of those famous stars that we use as a measure of distance. And I decided that one of my projects this year is to actually try to take multiple photos of it over several nights and see if I can track its brightness difference. It seems like something basic that all of us should do sometime in our lives. And if we go off to the right, we've got Pegasus. And if I were to bring out so many of the deep sky objects in this area, there's just too many to cover tonight. So there's a lot of star clusters in this area. The one that's my favorite is the Planetary Nebula, NGC 40, which I've marked on the map. And this one, I started taking pictures of it with my 3-inch telescope, and it just looked like an out-of-place red star. And then as I used a larger telescope, I could see it's just this beautifully red nebula, which I don't know why it's red. I supposedly could look that up, but it's fun to figure out what that is and then start to try to figure out why it's that color. But it's something you may want to look at and try to get an image of. And if you go a little higher, there's items like the Cocoon Nebula and a few other, the NGC 7331 and Stephan's Quintet are some famous galaxies that if you have a rather high power telescope, you might want to try to get a view or an image of. And if we go even farther this way, we come to what's overhead right now. And we have Cepheus here for reference. And here's Cygnus the Swan. So Cygnus the Swan, as soon as it gets really dark, is positioned high in the sky, which makes it very difficult to look up at, but it also means you're looking through less air, so it's a good target with the telescope. And I love Cygnus the Swan. It's one of those constellations that really looks like its name, down to the symmetrically and the little graceful wingtips of Cygnus the Swan. I love pointing that constellation out. And of course, the summer triangle is still with us here, and the three bright stars high overhead. And those regions are just rich with things to look at with binoculars too. You can see a double star in there. And this little area on a dark location, you can almost detect a hint of the North America Nebula in binoculars. A dark location's a must. That area near the star Satyr is a beautiful area to scan in binoculars and telescopes. And of course, the famous line of sight double star that has a great contrasting color, Albireo, the head of Cygnus the Swan, is right there. I've been able to split that detectably, that as I could tell, I was looking at two different color stars in a 7-power pair of binoculars mounted and handheld in a 15-power pair of binoculars that were image stabilized. As we go, oh yeah, from there, there's a nice little star cluster called Brocchi's cluster. We often call that the coat hanger. And if you come down from there, you might see another constellation that looks a lot like its name, the Delphinius, the dolphin. And it looks to me much like a little dolphin. And let's see what else I put in there. Okay, we go a little farther from there. We got Aquila. And here's just a kind of an overview of many of the objects that you may see in this area. So a lot of them are nebula. Some of them need to be photographic objects. And but it's just a beautiful time getting a little overhead view of Cygnus the Swan. And my favorite are planetary nebula. These are all planetary nebulas, essentially small stars that blew out their outer layers, and now their cores are illuminating those outer layers. And they usually are beautiful green and blue colors and often have little spiral shapes in them. And so there's a whole mess of planetary nebula in that area to look at. And I've just picked out a couple of my favorites that I've been able to image so far. NGC 6905 is near Delphinus, the dolphin, and the one on the right is often called I think it called it the blinking nebula, because it's usually just at the edge of detectability to our eye when looked at through a medium-sized telescope. So it always looks like it's blinking in and out. And M27, they call that the dumbbell nebula, I think, because anybody can find it and image it. And then, okay, from here, we'll go a little farther. We'll go plunging down into the southwest, and I'll do a quick scan of that area, which we looked at before. We've got the constellation Sagittarius and Scorpius. And if you follow the stinger of Scorpius, you'll see a couple star clusters that are great in binoculars as well as in a wide field telescope. This area is beautiful, just as a mass of stars to look at with binoculars. And here these objects show up in binoculars, but each on their own are a very nice telescope object. And here's a couple that I've managed to try to show how they might look in binoculars, though not with all the color. And up here, the star cloud, the M24 star cloud, and M25 and 23 open clusters. And a little higher, M17. In this famous one, I think they call that one the Eagle Nebula. I'm not sure if I got that right, but I can't actually put my glasses on. M16. And there's just a beautiful smattering of different types of objects right now. And it's kind of one of the last good times of the year to see them. And there's also, in addition to these nebula and open star clusters, a couple very bright globular clusters. One you find off the tip of and it's M20. Another you can right here by part of the Scorpion, and call that M4. And so those two are very beautiful objects. So you can just see them as fuzzy dots in binoculars, but also really well in telescopes. So there's the sky. This picture I took a couple years ago at the Joshua Tree star party that they're having again this year in October. So I left that one there just as a little reminder, just to make that announcement too. So anyway, thank you for your time.
Thank you very much, John. And the padding made it even more fabulous. Thank you.
Hey, Reza, this is Doug.
Yes.
I'm going to cut off questions at 9 o'clock for the on-ground people, okay?
Okay.
So if you don't get your question answered, then the speaker will be available to talk to him personally and come down and talk to him. But that just shortens down the meeting for people who need to get away, okay? So, Reza, take it away.
Okay, sure. So our speaker tonight is an astrophysicist, educator, and award-winning author whose work ranges from NASA projects to textbooks like The Cosmic Perspective and Life in the Universe, as well as acclaimed books for the public and for children. He created the Voyage solar system model on the National Mall, developed popular science education tools, and has been honored nationally for excellence in science communication. It is my pleasure to welcome Dr. Jeffrey Bennett. Jeff.
Is that on? Yep. All right. Thank you very much for having me here tonight. Do we have that presentation up? All right, great. We're going to go very, very fast since we're getting a bit late here tonight, and hopefully I'll keep you awake. So the title of the talk is Pathway to a Post-Global Warming Future. Let me start out by saying I'm an astronomer, as was mentioned in the introduction. You might wonder why I'm talking about climate change, and the answer hopefully will become clear as we go along. This is an astronomical topic. We learn about it through astronomy. What is a post-global warming future? Well, you see the photo here from the famous Earthrise photo from the Apollo astronauts in 1968. And what you can see is, well, you can't quite see it, but that photo inspired a lot of the environmental movement. And at that time, the climate there was very different from the climate that we have today, the physical climate. So a post-global warming future is a future in which we've restored the climate back to more like what it was at that time, so that sometime in the future, our kids, grandkids, whoever will be able to say, you know, global warming was a really serious problem, but it's in the past now. And so I want to talk to you about how we can get there and what it would actually mean to do so. Is this working?
Yeah, Alan, we don't have the presentation. Okay, great.
The advanced doesn't seem to be working here. Oh, there we go. All right. What is the future? So I'm going to go very, very quickly and just get to the key point here, which is that for anyone who has been born since about the year 2000, it is very likely that they will still be alive in the year 2100 and perhaps beyond, especially when you consider the possibility of advances in medicine extending lifespans somewhat further than they are today. So if life expectancy is 100 by the end of this century, that means anybody who's under about the age of 25 now is still going to be alive in the year 2100. So when you hear the media talking about global warming, what you usually hear is what might happen by 2030, 2050, but that's not really the right time frame to be talking about. We need to be looking much further along to be thinking about what it's going to be like at that time, 2100 and beyond. And if you think about global warming the way we usually hear it talked about in the media, you would think that that future in the year 2100 and beyond is going to be either bleak or bleaker. And that has led to a lot of what's sometimes called climate despair. Fortunately, it doesn't have to be that way if we understand the problem and make wise choices about how to deal with it. And so that's what we're going to be talking about. And of course, you can't help in the current environment notice that there are some people who don't want to face this problem. And I will just remind you, if you're concerned about that, hope is a choice. It's easy to lose hope at this moment, but we need to keep it in order to stay on track for doing what we need to do. And so now I want to get into the science, consequences, and solutions, and to explain so that you'll be able to talk to other people about how we know this is real and what we can do about it. So here's where the astronomy really comes in. What you see here on the screen, Earth and Venus shown to scale, and what you notice immediately is they're both the same size. They also are both formed in very similar ways. Their contents, if you cut them open, would look very, very similar. And therefore, in most respects, can you still hear me okay? I know I might be having some sound problems here, but in most respects, these two planets are as close to being identical twins as it's possible for planets to be.
I'm sorry, we have a really cheap sound system. So talk across the microphone and I'll turn it up. Talk into it. Talk.
Okay, across like that. All right. They're almost identical in almost all ways, except for their global average surface temperature. Earth is very pleasant, Venus hot enough to melt lead. And so if you're thinking about this in a scientific, astronomical way, the natural question is, why would two planets that are so similar in most other respects differ in this one big way? And the answer that most people guess is that it's because Venus is closer to the sun, which is true, but it turns out that doesn't explain the difference in temperature. In fact, even though Venus is closer to the sun than Earth, it turns out because it has so many clouds covering it, it actually gets less sunlight on its surface. So you would actually expect Venus to be colder, and instead it's much warmer. So why is Venus so much hotter than Earth if it's not because of distance from the sun? And the answer is the greenhouse effect. And the greenhouse effect, I won't go through it. Hopefully you've heard of it before. We don't have enough time to go into details, but the greenhouse effect is caused by these molecules in the atmosphere that we call greenhouse gas molecules. On Earth, the three main molecules are water vapor, carbon dioxide, and methane. And they reflect infrared light that's headed back out to space from the ground, with giving the net effect that the more greenhouse gas molecules you have, the more energy is trapped down near the surface of your planet. So for Earth, at the surface, in the lower atmosphere, and in the oceans. How do we know that it's the greenhouse effect? Well, there's basically two lines of evidence that tell us the greenhouse effect works the way that picture just showed. The first is you can actually measure the greenhouse effect in the laboratory. Basically, you put gases like that into tubes, shine light at them, measure what happens with different wavelengths of light. And this is not new science. I actually had somebody ask me the other day, what can you tell me that's new about global warming that'll make me believe it? And I said, well, that it's not new. We've known about this for more than 150 years. It's been measured in the laboratory. The earliest measurements were done by a woman named Eunice Newton Foote in 1856. By 1859, that was the experimental apparatus that John Tyndall was using to measure the greenhouse effect. By 1896, this was so well known that the chemist Svante Arrhenius actually calculated what would happen if we doubled the carbon dioxide concentration in Earth's atmosphere. And his calculation comes out basically exactly the same as what the most sophisticated climate models will tell you today. So we've known what would happen for 150 years. That's assuming it works the way it does in the laboratory. How do we know what happens in the laboratory translates to the real world? Because we can test it with real worlds. We can take those laboratory calculations, use them to predict the temperatures of real worlds based on their greenhouse gas concentrations. And guess what? If you do that, you get the right answers for every planet and moon with an atmosphere. If you try to do it any other way, you don't get the right answers. So we have real world validation that the greenhouse effect really does work that way. Also worth noting that without greenhouse effect, Earth would be too cold for life. The natural greenhouse effect is the only reason our planet is warm enough for us to be here. And so that brings us to the conclusion of our tale of two planets, which is that the reason for the difference is because we have enough carbon dioxide so that our planet is not frozen and we can live here, So the greenhouse effect, as it naturally exists, is a very, very good thing for life. We wouldn't be here without it. Venus is so hot because it has about 200,000 times as much carbon dioxide in its atmosphere as Earth does. And that is just absolute proof that it's possible to have too much of a thing. We're almost done with the basic science of global warming because now we understand what's causing it, the greenhouse effect. What's the warming part mean? The warming part means we're actually putting more greenhouse gases into the atmosphere, which means it's going to warm up, right? So how do we know we're putting more greenhouse gases into the atmosphere? Because we measure it. And there you can see the famous Keeling curve. These are the measurements from Mauna Loa and Hawaii, and you can see the concentration has gone up substantially. I won't go into detail, but there's no doubt that the reason for this is primarily the burning of fossil fuel, 90% of it due to the burning of fossil fuels. We can track that through isotopic signatures and other things. We've only been measuring that rise in carbon dioxide concentration since the late 1950s, but we can get data from earlier times through various geological means, including ice core studies. And in fact, ice core studies give us an 800,000 year record of Earth's carbon dioxide. And you can see that it varies substantially over time. And those are obviously natural variations. But what we're doing today is clearly out of character with the natural variations that have been happening over the last 800,000 years. In fact, we're now 50% higher than any time in the last 800,000 years. And if you extrapolate that curve upward, if we keep doing what we're doing today, we would be at double the pre-industrial concentration in about 50 years, triple that by the middle of the next century, and so on. So way out of character with the past. And so that allows me to summarize the science of global warming with what I like to call global warming 1, 2, 3. So number one is fact that carbon dioxide and other greenhouse gases make planets like Earth warmer than they would be otherwise. There's no disputing this fact. You can talk to the people who wrote that report for the Trump administration who say we shouldn't worry about this. They're not going to dispute this fact. They acknowledge this fact. Fact number two, that we are putting more greenhouse gas into the atmosphere. Again, no from anyone. And if you put number one and number two together, number three is it's going to get warmer. There's just no doubt that that's going to happen. So what are the people who wrote this recent report for the Trump administration saying? They're basically saying, so what? But they're not denying that this is going to happen. And we'll talk about why so what is probably not the right answer. There's the temperatures. And guess what? They're going up exactly as we expect them to. No surprise, because the 1, 2, 3 science says it's got to be that way. Incidentally, you'll notice the last 11 years here are the hottest 11 years in the entire temperature record that we have available. And we can also look back at the last 800,000 years. Before I showed you the carbon dioxide concentration, now I have it overlaid in red with temperatures. And you notice, well, first of all, you notice that carbon dioxide and temperature go together. They have to. That's the 1, 2, 3 science. There's no doubt about this. And you also notice these are big differences in temperature. If you look at the temperature scale over here, so it's quite cold in all these bottoms. These are all ice ages. And the interglacial periods are much warmer. And you can see we were already in an interglacial period before we started warming things up even further. That's been good for humanity. That's how our civilization was able to come up. But pushing it at this rate upward is not a good thing for us. Excuse me, grab my water here. So I'm at my quiz question point here. This science, this basic 1, 2, 3 science is so simple that you would think even politicians would be able to understand it. And it turns out some of them have. So who was the first major global problem and we need to deal with it on the international stage? Guesses? Al Gore is the most common answer that people give. It turns out he might have been aware of it before this other person, but he was not the first person talk about it on the international stage because in 1989, he was just a senator from Tennessee. Nobody really knew about him outside of Tennessee or people who paid close attention to U.S. politics. Margaret Thatcher in 1989, what we are now doing to the world by adding greenhouse gases to the air at an unprecedented rate is new in the experience of the Earth. It is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. So if anybody ever tries to tell you that global warming is some kind of liberal idea, here's one of the founders of modern conservatism, was the first major global leader to speak out about the absolute need to do something about this. And many other conservative leaders over the decades have spoken out about this just as loudly. In fact, just in case you think, well, what about today's conservatives? You know, here's a quote from another conservative. If we fail to act now, it is scientifically irrefutable that there will be catastrophic and irreversible consequences for humanity and our planet. This was a quote that this conservative wrote as part of an op-ed advertisement paid for in the New York Times. You know, those cost like $100,000, right? So this leader, along with a few others, signed this letter saying we need to take immediate, fast action on global warming, much more so than we're doing. Who was it? I'll let that speak for itself. All right, I said we're going to talk about science, consequences, and solutions. So I want to go very, very quickly into the consequences of why this is not something that we should just say, so what about? Because there's lots of consequences. I like to divide them into 5 basic categories, and I'm just going to very, very briefly go through each one. The first is regional climate change. And this is the idea that even though global warming refers to an average increase in the temperature of the Earth, it doesn't change by the same amount everywhere. And here you see this map video showing you how it's changing in different places over time. Red is hotter than the average for the past 100 years. Blue is cooler. And as you can see, as we get out towards the 2000 and beyond, the entire world is heating up dramatically, but clearly some places much more so than others, especially the Arctic regions. There's shifts in temperatures. Temperatures form a bell curve. You look at like any given place at any given time, but the whole curve is shifting over to warmer temperatures, so that these are summer temperatures, in fact, shown here, averaged over the northern hemisphere. And very hot is now much more common than it used to be. Increase in extreme weather events. You've probably noticed this. You might think, okay, well, why would we expect an increase in extreme weather events? Because think about it. What is global warming caused by? Ultimately, it's that greenhouse effect getting stronger. The greenhouse effect traps heat and energy down in the oceans and the lower atmosphere. What causes weather? Heat and energy. More heat and energy, more extreme weather. It's obvious that's going to happen, and it is. And just incidentally, I don't have time to give you all the details, but we can actually measure how much energy is being added to Earth's climate system. And it turns out it's the equivalent, for example, of blowing up 8 Hiroshima sized bombs every single second, adding that much energy to Earth's climate system. It's insane when you think about it. The third major consequence, the melting of sea ice. So ice up in the Arctic Ocean. Remember, the Arctic is warming the most, so that's where most of the melting is taking place. The only good news is that this doesn't affect sea level because that ice is already floating, but it has lots of other consequences that are overall not going to be good for us. The fourth major consequence is sea level rising, and that's from ice that's melting off into the oceans, as well as expansion of seawater as it warms up. Just as an example, I've got Florida here, but you could do the same thing for California. What would a 1 meter rise in sea level do? And so the red areas are areas that would be underwater. How likely is a 1 meter rise in sea level? That's about the average guess, and it is somewhat of a guesswork right now of what we'll see by the year 2100, which, remember, all today's kids are still going to be alive. The fifth major consequence, ocean acidification, because it turns out only about half of the carbon dioxide that we're releasing into the atmosphere stays in the atmosphere. The other half gets absorbed into the land and into the oceans, and in the ocean, it turns the water more acidic. And that has lots of consequences, particularly when combined with the fact that the oceans are also getting warmer. So those 5 major categories of consequence, I think, will convince you that this is a serious problem that we need to deal with. The good news is, in principle, these are all reversible, at least so far. The concern is if we hit what's sometimes called tipping points. Tipping points are where they start to spiral out of control, often because they're feeding back with each other. If we hit a tipping point, then it would not be so reversible. So clearly, what we want to do is act before we hit a tipping point. When are we going to hit a tipping point? No one knows. We don't even have good guesses as to when that might happen. The IPCC says all the tipping points that you can think of are all low probability events individually, but we don't know exactly the probability of any of them or when they might occur. So now it's just a game of risk analysis, right? How much, the longer we go, the higher the probability we reach a point where it's no longer as reversible as it is today. And so if I stop there, you would think bleak and bleaker are the possibilities for the future. But fortunately, I'm not going to stop there because there's ways out. And the main way out is, I'll slow down for just a second here. Think about everything I've told you so far. This is a major problem. It's caused primarily by the burning of fossil fuels. How do you solve it? Not that hard, right? Stop burning the fossil fuels. That solves 90% of the problem. So what's so hard about that? Well, we use a lot of them, but it turns out we already have all the technology we need to completely stop burning fossil fuels immediately if we so chose, almost immediately, as long as it takes us to build stuff. No reduction in our lifestyles. How do we do that? Through a combination of 3 technologies, of 3 sets of technology. One is efficiency. Better efficiency means you get the same energy benefit for less total energy. Renewables, solar, wind, geothermal, and so on. And nuclear power, which does not release any greenhouse gases. Between these 3 technologies, if we really wanted to, we could immediately switch over all of our energy use to this and have the same lifestyle that we have today, probably at lower cost, and not be contributing to this problem anymore. And the good news is the change is coming. It's happening right now. Renewables are growing at a very rapid pace. Battery technology allows you to avoid some of the intermittency problems that we've had in the past. Nuclear power is being built in many countries around the world. Not so much here yet, but hopefully that'll change as well. So we have the technology. It is coming. And that's just with the existing technology. If you start to look at what we have in the future, you have all sorts of other possibilities. And again, I don't have enough time to go through all this in any detail, but I do want to talk about one of them just to give you an example. And that one is nuclear fusion. Because nuclear fusion, we don't have that technology yet. It's being worked on. But nuclear fusion is what the stars do, right? Fusing hydrogen, helium. And so just as a little exercise, it's fun. You can do this calculation very, very simply. Turn on your kitchen faucet, measure the amount of water that you're flowing through, the rate, number of liters per minute, and find out, look up, how many molecules of atoms of hydrogen there are in each liter of water, figure out how much energy you get from each fusion reaction. You do all those calculations, and it's very easy to come up with how much energy per second, right, power you'd be generating if you had Mr. Fusion hooked up to your kitchen faucet. Anybody want to take a guess at the answer? I think that's way under. Yeah. No, it turns out if you do this calculation, single faucet would produce about 3 terawatts of energy, or power, 3 terawatts. What's 3 terawatts? It's what the United States uses in total. A single kitchen faucet could replace every other energy source we have for the entire United States. 4 kitchen faucets could take care of the world. With fusion, if we had fusion. Do we have fusion? No. Are we working on it? Yes. When will we have it? Nobody knows. Would you bet by 2050? Maybe. Would you bet by 2075? More likely. Would you bet by 2100? Personally, I won't be here to collect, but I'd bet you 100 to 1 we'll have it by the year 2100. And so I want you to keep that in mind when we go back to this idea of post-global warming future. We could stop making this problem right now, but I said post-global warming future. I don't want a climate as bad as it's gotten already. I want one that's better, which means we have to take the carbon dioxide level back down from where it is today. Well, there are technologies that are being developed to do that. Active carbon dioxide removal is one of them. There's a number of other possible ways of bringing the carbon dioxide level back down. And so with those things in mind, we can that there are just 2 simple steps to a global warming future, right? Step 1 is stop making the problem worse. Quit having that carbon dioxide concentration go up. That means we've got to switch over and get away from the use of fossil fuels.
Here's a new mic. Check 1, 2. Check 1, 2. Go ahead and stay with this one. I'm sorry.
All right, we'll stay with that. All right, so number 1, stop making the problem worse. That buys you some time that you're not going to be going after those possible tipping points to develop new energy technologies such as fusion or something else that you could use to power not only our society, but also things like active carbon dioxide removal and bring the carbon dioxide level back down. And if you do those 2 things, then you realize that by mid to late century, this century, we could have reached a point where the climate is being restored because we're bringing the carbon dioxide level back down. But that's not the only part. Remember what the amount of energy available from fusion as an example. If we achieve this ability to get these kinds of energy sources, bring the carbon dioxide back down, it will be because we also have basically cheap, virtually unlimited energy available. So when you think about a post-global warming future, it's not just that we've restored the climate, it's that we've done it at the same time. We've got an enormous abundance of energy compared to anything where we might conceive of at the present time. So that brings me to kind of the conclusion here that I started with a tale of 2 planets. Now we've got a tale of 2 futures on this planet. The first is if we don't act quickly, is indeed bleak or bleaker. But if we do act quickly, the future is not just the climate getting better, but it's that we've got all this energy available. What can you do with all that energy? You could easily eliminate poverty, since poverty is very closely tied to energy. You could desalinate water so you have no more freshwater problems, remove all the dams so that you just get your water from seawater instead of having to block rivers. No more mining on Earth, because with all that energy, just go get your mineral resources from the moon or asteroids. So you can basically turn the Earth into a national park. And so much more. So the post-global warming future is not, it's not only not bleak or bleaker, it's really amazing. That's the future that we could have in this century if we act now. Now, how do you get people to focus on that? Well, there's a few ways you can do it. One is if you're for the young people, if I do this talk with high schools or colleges, I usually ask them to do this exercise. It's your 100th birthday, which in their case will be in the year 2100 or beyond. Write your story. How did we achieve a post-global warming world, and what role did you play? For those of us who won't be around in the year 2100, we can think about it a different way. Think about writing a letter to your grandchildren. Now, why do I pick this particular extra? Because what we hear in the media all the time, not just about global warming, but about other things, is that we're all polarized, right? The left and the right can't agree about anything. But that's not quite true, because I bet if you talk to anyone anywhere across, tell you the same thing about their kids and grandkids, or what they want for them, which is they want a better world for their kids and grandkids. That is a universal sentiment across all political persuasions. We want for our kids and grandkids. So imagine writing this letter. As I write in 2025 to your grandchildren, many people are arguing what is real and what we should do about it. I have examined the evidence. I've decided to fill in your decision. Hope your world is a good one. Love, you. I think if everyone actually thought about this and wrote a letter like this and sealed it in a time capsule for their grandkids to open 50 years from now, say, we might find everybody going, you know, maybe I should take this seriously and do something to make sure that my kids and grandkids end up in a better world. So thank you for bearing with me as we went very, very quickly through all this. I just want to point you to a couple of resources. My book, A Global Warming Primer, Pathway to a Post-Global Warming Future, which just a couple months ago, I was notified won Book of the Year for environmental category from the Forward Indies Award program. I have a children's book that does this same topic, The Wizard Who Saved the World, that was read from the International Space Station there. And I have a free online middle school version of the climate chapter that you can get there. And those are all the rest of my books. Incidentally, my book, Max Goes to Mars, over there, just came out in a new edition last week. I hope you will check those out, and you can go to my website to learn more about them. Thank you.
Thank you very much, Doc. So the floor is now open for questions. Shall we start from in-person, Doc?
In-person? Anybody have questions?
The question is the medieval warm period. So there's a couple things about that. Number one, the medieval warm period looks apparently to have been a localized warm period. The whole Earth was not that much warmer. There was a little bit, but look at the data. This is the famous hockey stick graph. Look at the NRC report. People claim that, but the National Research Council did a report on it. They've done multiple reports on it. Every other study that's been done to look at that has come up with the exact same conclusions. So you can deny reality, but it doesn't change reality. Yeah. For the kitchen faucet one, I'm doing it on the hydrogen. So if you do it by deuterium, you need to multiply by 6,400, since deuterium is 1 part in 6,400. Are there any online questions?
Yes. What are your thoughts on the potential effects that warming climate might have on ground-based optical astronomy?
You know, that's a really good question. I think as far as warming climate in of itself does not have much impact on ground-based optical astronomy, other than the fact that there's more moisture in total in the atmosphere. So that's going to have some effects, and more weather events that might be affecting observatories, right? So we had observatories threatened by wildfires recently. So those kinds of effects on astronomy.
Would it be effects such as increased absorption due to water content in the atmosphere or impacts on atmospheric stability?
Well, yes, that's what I mentioned. There is a higher water vapor concentration in the atmosphere because there's more evaporation. So that'll have some effect. I think that's probably fairly limited compared to the threats that observatories are likely to face in things like wildfires and other extreme weather events. But I would say, from the astronomy point of view, we're probably not the most impacted group, but everyone else is, and we are by virtue of being human beings.
Sure, thank you. Sorry about that, because sometimes your voice cuts off and we do not hear parts of your...
Sorry.
Yeah. So we have another question, if I may. Can we get enough energy for a post-warming future without fusion, since it may not be possible, or could we meaningfully speed up fusion development?
Yes to both. There are many ways of getting this enormous amount of energy besides fusion. Solar on the screen there with the slide I had, for example, solar energy from space, advanced biofuels that might be developed. One of my favorites is deep geothermal energy, right? Geothermal right now only really works near volcanic sources. The reason being that we can't drill deep enough. But if you drill down 20 kilometers, you can tap geothermal anywhere on Earth. You could go to every fossil fuel plant in the world, just drill down 20 kilometers and replace the fossil fuels with the heat loop circulating down to 20 kilometers depth. So it's really just a drilling problem, and people are working on that. So if we had deep geothermal, we'd have an enormous amount of energy available as well. And fusion, there's lots of people working on fusion, so we can probably speed that up also.
But isn't geothermal very limited on where you are? If you're in Iceland or...
At the present, it's limited because of our limitation. Drill down 20 of depth in the crust where it's hot, no matter where you are in the world. So basically, if we can learn how to drill that deep, then geothermal is available everywhere.
Okay, thank you. We do have a couple of more questions online, but let's see if in-person audience have any questions first.
Yeah. Oh, so two things. So biofuels, just the question is why would biofuels be more favorable than fossil fuels in terms of global warming? So biofuels, if you do them in an actual renewable way, this is not true of ethanol the way it's being currently done, but if you actually did it, then just right off the bat, to grow it, they absorb carbon dioxide, and then when you burn it, you release that same carbon dioxide, so there's zero net change. But you can actually also do it where they trap more carbon dioxide than you release when you burn them. That's sometimes called biochar. That's the residue left behind that just gets buried. So they can actually not only be net zero, they can actually help bring the carbon dioxide level down, because every time you grow them and burn them, the net is actually pulling carbon dioxide out of the atmosphere. Do another online question?
Yes. This questioner wants you to repeat the energy available from fusion, because the audio was cut off when you were mentioning what kind of energy is available from fusion.
So if you do the calculation for a single kitchen faucet, assuming ordinary hydrogen fusion, it's about 3 terawatts. So it's what the United States as a whole uses.
Okay, great. And the other questioner wants to know about how can we make solar energy available to everyone?
Solar energy is available to everyone, at least if you have a rooftop or something available already, because it's there all around the world. So that's a matter of politics and cost, right? We know how to build solar panels. We know how to put them up and energy from them. if we, and so, yeah, you want to find a way. For example, I heard somebody talking about China there. China is selling most of the solar panels around the world right now. I just read yesterday in Africa, their imports of solar panels are up 60% from last year to this year. Because in Africa, solar panels are way, way easier than building power plants, right? To get electricity to people who don't have it. And that's all being sold to them by China right now. So if you're concerned about the United States economic health, you would want to be competing on that.
Great, thank you. And
There's
are
one
there any prompts? Yes, sir.
Oh, there's one on the floor over here.
Oh, okay.
So let me point out to you, because we don't have time to go into great detail. I have a chapter in my book called The Skeptic Arguments. That one, your one about the hockey stick, there I've addressed all of them in detail with citations. So if you have any questions about that, please read my book, okay? It's a feedback loop. So again, we don't have time to go through details. This is very easily explained. The Earth goes through natural cycles, the Michelangeloid cycles. When it warms up a little bit because of the sun, that is going to warm things up, release carbon dioxide from the oceans. The more carbon dioxide from the oceans is going to make it warm up even more. So it's going to amplify, self-amplify. It doesn't matter which one starts first. It automatically self-amplifies, and the same thing on the way back down. All right, now we had another question online.
Yes. Are there any promising carbon neutral extraction methods to use hydrogen as a combustion fuel?
So to use hydrogen as a combustion fuel, you need to either make the hydrogen or get the hydrogen without using fossil fuels. You can make the hydrogen from renewables, wind, solar, or from nuclear. In general, that's not very efficient because it takes a lot of energy, and you'd rather use that energy for something else. There has also been some recent work on whether there is an available hydrogen source bubbling up out of the ground. And it appears that there is. Whether it can actually be tapped in an economically efficient way is not yet clear. Saw another one over here. We have another question on the floor here. Currently? Well, yeah, the international scientific collaborations are becoming difficult at the current time, mainly because of cuts to grants and so on in the U.S., the possibility of turning off climate satellites and so on. So I think we're in a period where nobody really knows how the scientific collaboration is going to be affected until yeah. Well, in terms of the climate data and measurements, the U.S. has been providing the majority of that. The Europeans have a number of useful satellites, and they are collecting a lot of data now. China is starting to collect a lot of data now also, but the U.S. has been clearly the global leader in understanding this, and we're hoping that will continue. Yeah, so the question is, will this just solve itself because of these technologies that are coming along? And I think the answer is, I think yes, which is why, I put up the choice slide in the beginning. It's easy to get discouraged by people trying to cut all these things that are going to help us in this area. But I think the economics are already so favorable for these alternative energy sources that one way or the other, it's going to happen. The other part of that is, again, China is leading the world in this area, followed by India. So if we want to keep competing economically, we're going to have to keep moving on this as well. So yes, I do think it would sort of take care of itself in that way. At the same time, you are worried about these tipping points that we don't know when they would hit. And so if we can accelerate this through various policy choices, that makes it even more likely that we get to the solution before it's too late for it to be reversible. Do we have another online question?
No online questions.
All right. Okay. Thank you very much.
Thank you very much, Jeff. What a wonderful talk.
That was certainly interesting, and you're welcome to come down and have a little chat if you have more questions. We'll see you on October. When was it? 17th. Remember that. And for more books and more fun. Thank you.
Thank you. Bye-bye, everybody.